Hey, thanks for coming to check out part 2 of my commenting application videos. So, like I was saying, the client and server communicate over WebSockets using JSON. So when the client wants to actually do something like update a comment, they create a new JSON message, and inside that message they place a field or a property called event, which contains an action that the client wants to achieve, and the server reads this JSON and passes it and grabs the event property out, which ultimately decides how to handle the request. So to explore this idea a little bit more, here's an example of the JSON message. So the client creates this JSON message when they want to actually do something. So here they want to update a comment. The message has some additional data like what field's being updated, and here's the actual payload, the comment being updated. So here it would have an updated vote count. So when the Java server WebSockets implementation has the onMessage method called, what happens is it passes the incoming JSON and reads the event property. So here's the class on the Java side that actually does this. Here's the onMessage. It extracts the event out of the JSON object. We just have a switch statement here which, according to the event, dictates what actual method gets called to handle the request. So it's quite simple, but it works quite well. So continuing on with that, after we know what the event's for, then the appropriate method gets called. And this is the next stage here. So on my GitHub page I've mentioned a number of technologies I used on the server side, and here I've used Jackson and Morphia. So basically Jackson converts an incoming JSON message to a comment object. So I've created a comment object on the Java side to represent a comment, and Jackson basically converts JSON to objects and objects to JSON, which is quite convenient. And Morphia is like a Mongo ORM tool, which essentially converts a Java object to a Mongo document, and then a Mongo document back into a Java object. So a client creates JSON. JSON comes into the server. The server reads the event field or property from the JSON. This field decides which method is called. For example, using the onCommentUpdate method will get called. From here, the JSON would get converted into a Java comment object, and once we have an object, we can just use features of Morphia to say, here's a comment I want to save or update to Mongo, and then Morphia will go ahead and save it to a Mongo database, and if it's an existing comment that needs to be updated, it will just go ahead and do that. So then once the comment is saved, then everyone will receive the new update. So Jackson will convert the comment back to JSON and dispatch the new updated JSON to every client who registered to receive new comment updates. And how do we know who actually receives these new updates is decided in the initial connection setup stage. So after clients connected to the WebSockets server, they request the server to subscribe them to receive any new comment activity. So here's an example JSON, very simple, it just contains an event, and the server reads this event, and all the server does is add their session to a set containing comment subscribers. So this set's just in the background purely for keeping track of all the latest comment subscribers. So once they've subscribed, then a call to MongoDB's action to get all the latest comments, and then we send the client who requested the subscription back an array of all the latest comments so they can populate their comment feed. And that's basically how that all works, and the same things apply for any other action that needs to occur as well. just using the event and sending whatever data needs to be sent backwards and forwards between the client and server. So some other things I did to challenge myself, for example, when I have the comment feed on, the filter on the comment feed, because WebSockets is used, there's many different new comment requests coming through. So if the filter's on, we need a way to store these new comment changes somewhere, so that when the filter's cleared, we can restore the comment feed again. I could have quite easily just requested the server to send all the latest comments again, but instead I decided to do something a little bit more challenging in order to avoid having to recontact the server again. Essentially, all I did was implemented a few client-side caches to store all the new incoming comment activity while the filter was on, and when the filter was cleared, essentially the comment feed was reconstructed, and that reconstructed comment list was what the server would also see, because I was keeping track of all the changes on the client. So that was a nice feature I enjoyed implementing. But that's pretty much all I have to say for implementation side of things. But thanks for watching both videos if you have, and I hope to catch you next time.